conceived by Takwai, who's been having these very interesting panels and talks. I would like to acknowledge the APSI, that's Asia Pacific Society for Computers in Education, MetaACES theme-based international conference series, which I think Takwai chairs, and the special group of AI Education and Society, the National Science Technology Council in Taiwan, for hosting this particular panel. I think we are going to have a series of 3 panels. There are going to be 2 more after this. So our panelists today are really well-known researchers in artificial intelligence and education, and also in learning companions and pedagogical agents. I decided, this is somewhat arbitrarily, but I have a reason. So James Lester and Louis Johnson have one of the most cited papers on artificial learning companions. So I thought I would give James a chance to sort of start off this panel. And James, I think we decided that you will give an overview of artificial agents as they have evolved through the years, the last 40 to 50 years. Then we'll go with Claude Frasson from the University of Montreal, followed by Louis Johnson from Alelo, Art Graesser from the University of Memphis, and then last, the host, Chen-Chung, if you don't mind. So, but we'll looking forward to each one of your talks. Let's keep it to about 15 minutes each, and then at the end, we will have time for open discussions. So I just wanted to remind you the theme for this particular panel is the role of generative AI in building humane artificial learning companions. I'll stop sharing, and James, if you'd like to start, it's all yours.
Great, thank you, Gautam. Can you see my screen?
Yes, we can.
Yes.
Excellent. So I'm going to be quite frank about my day today. So I was having a really nice meeting with Gautam this morning, and he said, James, how about tonight you give a talk about the history of pedagogical agents? That was about 6 hours ago. I have put together, at Gautam's request, a sort of pictorial history of the history of pedagogical agents. And in many ways, this is sort of an old family album of pedagogical agents. And this is all drawn from collaborative work. I'm so happy that Louis is here, and our old friend, Jeff Rickel, who contributed to much of the work in our field, really launching it. As promised, this will be a very short presentation, sort of a march through history, and it's maybe slightly tongue-in-cheek. I hope for whatever time of day you're in, that will work for you. So pedagogical agents actually did not begin with pedagogical agents. Pedagogical agents began a long time ago, even before some people on this call were working on pedagogical agents, and that was with Jack. Some of you will know that there was an enormously interesting family of projects at the University of Pennsylvania in the 90s, and maybe even predating that to the 80s, of Norm Badler and his colleagues working on some incredibly interesting kind of intersecting technologies between what was then computer graphics. So these would often be presented at graphics conferences, SIGGRAPH, and AI. One of the surprising functionalities that shows up in many of these agents is actually illustrated in this photo of Jack. So all the agents were called Jack. And you can see that Jack is pointing. So pointing was a really big deal back in the late 90s, and there was actually a good amount of work in getting agents to point. And I want to make a kind of meta comment here as well, which is everything that we're seeing here as it's kind of being born in real time as we're zipping through history. Many of these things come up again. I think we're going to be seeing, I'm predicting, we'll be seeing in the upcoming talks, because all of the same kinds of communicative functionalities that we see, including gesture and posture, facial expression, gaze, the coordination of all of those with speech, all of these same communicative functionalities are required now, but now we have the technologies to really do them in an incredibly, incredibly interesting way. So, so that was Jack. And then, and I say this not just because Lewis is in the room, but I think that in many ways, probably the most early pedagogical agent was Steve. So Steve, I remember visiting ISI in those days and just being completely amazed by this wondrous creation by Lewis and Jeff. So Steve not only was able to talk to you and use speech synthesis, which is an amazing feat for those days. It could interact with its environment. So here you can see it manipulating a device. I think it was a ship or a submarine. And this was all in a VR headset. So, you know, it's hard to imagine that this, gosh, 25-ish years ago, something that is now still found to be pretty challenging, Steve was able to do. And something I think is really notable about Steve, and this is unlike a couple of agents that we're about to see in a moment. So Steve, I think, really had particularly sophisticated AI running under the hood, meaning that there was a planning system. So the planning system would kind of integrate the planning of Steve's behavior. So it's demonstration behaviors, it's behaviors for providing explanations, it's kind of diagnostic behaviors as it was teaching procedural knowledge to students. And it would do all of this in real time, which again, just thinking about the processors that were available then is pretty astounding. I will say in passing that if you look to the figure on the left, I don't know if you can see it, the resolution on your screens or not, Steve does not have a bottom half in this particular era. So Steve floated freely, which I think actually made it a good bit easier for him to move around the virtual environment. But that's an example of the kind of sort of constraint removal techniques that we designers of pedagogical agents often use. And my prediction is that we will have fewer and fewer of those that we're going to have to relax as the months go on, not just as the years go on. So Steve really brought together, I think, all of the core functionalities that we now understand that a pedagogical agent has to have. And it did it in a really remarkable way so many years ago. So now I'll turn to one of the agents that was developed in our lab, Herman the Bug. This was for a really, I think, at the time, interesting game-based learning environment. So this was a system designed for middle school students, where students would have to design a plant that could thrive in a particular kind of environment. So there were different environments that they had to design plants for. They had to select parts based on their knowledge of botanical anatomy and physiology that would not only fit together, but would allow the plant to do well in the environment. But all of that's really, for our purposes, just sort of the backdrop to this little agent. One of the interesting things about this agent is that it very much combined what at the time was kind of a new recognition in the animation industry in a book from Disney called The Illusion of Life. So all of the kinds of movements of Herman the Bug in this environment were governed by these principles of animation. So we actually had a team of animators that animated all these tiny little we call them behavior clips, that would sort of play out Herman's behaviors, and he would not be stationary, but moving through this very, very, very simple 2D environment. And he, in some ways, like Steve, but I think in a simpler way, provided many of the kinds of functionalities that we've come to understand as being central. So, for example, he would provide explanations at different levels of detail. He would proactively intervene if there were extended pauses, the most rudimentary way of sort of detecting either disengagement or frustration or confusion on the part of the student. He would also have this ability to perform these kind of believability, this is what we call them, believability enhancing behaviors, which were lifelike behaviors that would really kind of provide a kind of a type of engagement for students. And again, these were middle school students. So, and I think we all now have a much deeper sense of how important engagement is. The bar for engagement, I must say, is considerably higher now than it was back in the late 1990s. And the way it worked was having this enormous, and I'm showing this for not what it did, but for what it didn't do. It had this enormous collection of tiny little behavior clips that it would knit together in real time to produce Herman's sort of physical behavior in the world, but also his spoken behaviors, and even it would have this customized soundtrack that it would put together underneath. And if you think about those kinds of problems for 2023 and 2024, we're going to be seeing generative AI do all of these things and doing them with such capabilities. Our problem, I think, very clearly now is not the challenges posed by generation. It's the problems posed by overgeneration. This set of technologies can generate so expressively that it's problematic, and that's an interesting set of issues that we're now grappling with. I just wanted to point out that it wasn't just all black and white family photos. There actually were color family photos of these agents. And there's I think a really interesting comment about the distinction between the color and the black and white. And I think we're going to be seeing the same difference in 2D versus 3D, and just the level of immersiveness that we're going to be able to be achieving between VR across AR. So then just skipping ahead, I'm going to speed up just a little bit here. We're going to start making the clock go forward faster, just in the interest of time. But a significant area of work is on deictic control. That is, being able to generate deictic expressions. This is a particular agent called Cosmo that was developed in our lab, and being able to refer in real time, both through linguistic expression, but also through gesture, to objects in the world. And this has become almost simplistic to do, but it's an example of the fact that we've got this kind of family of behaviors that are really important in learning, that are playing out over and over and over again. And it's going to be really important, I think, to be mindful of making sure that these new technologies that we're bringing to bear are really directed toward making learning better, and not just by what the system can do this week as opposed to what it could do last week. Just for fun, for the folks in the room who can remember some really nice work that was done at DFKI by Elizabeth Andre and her colleagues, again, pointing. And just to note that, in fact, at DFKI, they were doing some really interesting, very much like Steve, plan-based representations and reasoning to drive the agent's behaviors. So now, zipping ahead to the modern era, which we're taking to be roughly 2015, Work began in earnest on a family of projects in our lab on narrative-centered learning environment in Crystal Island. I think this is a trend that's, and I'm not completely objective about this, but I think this is a trend that's going to become incredibly important as we begun to recognize the power of story in learning. And really trying to leverage the power of narrative by embedding pedagogical agents in the narratives to provide explanations, to provide hints, and in some ways, most importantly, to drive both the narrative and the learning forward. Some very interesting work by our leader here today on teachable agents. And I'll say this is a family of projects that, again, has been running for a long time. And others in our community, notably Noboru Matsuda, has also been working on teachable agents, I think, like Gautam, in many, many interesting ways. And because these elicit the self-explanation effect, I think they'll continue to become even more important. I could not conclude this talk by without showing the fabulous work that Alela was doing 5 years ago. And to me, this looks incredibly contemporary. We'll be hearing from Louis in just a moment, showing us the fantastic things that Alela is up to these days. But I think, again, this shows the enormous capabilities by integrating speech and language for cultural training and also language training in incredibly interesting ways. So just to wrap up, I think the future of everything, and this is no original thought by me, is going to be generative AI squared or cubed or something like that. So we're going to be seeing narrative-centered learning environments where every element of these experiences are being generated. So the plots, the character behaviors, the coordination of those being driven by incredibly expressive and very powerful student models, all driven by what, again, Gautam is working on in multimodal learning analytics. So the kinds of information that these systems are going to be able to be informed by is so much richer than we had before. So with that, I will conclude and say I'm very much looking forward to hearing from all of my old friends, and I mean friends from a long time ago, not commenting on age, what they have to say about what's next. Thanks so much.
Yeah, thank you very much, James. That was a great start to the panel. Claude, if you are ready. Claude Frasson ready? Great. Claude, I think you were muted, so if you... There you go.
Yes. Good morning or good evening, I don't know, but for me it's morning.
Early morning.
So thanks to Takwai and his team for making this meeting available. I would like to make a short story of the companion. The origin studying with the prince is a paper from Takwai that we accepted at ITS 88 in Montreal. And the history of the companion started from this paper. In the past China, there was a child who studied under the instruction of royal teacher. And the queen had recognized the importance of a learning companion. The companion learns to perform learning tasks about the same level of a student, and both students can exchange ideas while being presented the same material. For instance, in case of difficulty, the learner can ask the teacher, who is the authority, of course, or the learner can look to the companion for assistance in order not to face the teacher with a problem. The teacher intervenes when both the companion and the learner cannot solve a problem. In 1996, it was yesterday also, we built in Montreal a special kind of agent called troublemaker in order to test the self-confidence. The troublemaker is a companion who can lie and give sometimes right, right suggestion and sometimes wrong answer or suggestion in order to force the learner to read and propose the right solution. So the learner has to justify and give explanation to the troublemaker under the control of the teacher. And if the learner is unable to give a correct solution, the teacher gives him the solution. This strategy is useful for building self-confidence and obliging the learner to distinguish between wrong and correct solution. We will see that this approach is important for the future of future companion. About the evolution of of AI, I have had some discussion with my colleague Joshua Bengio at University of Montreal. You know Joshua, who is a world leader in deep learning, machine learning, and neural networks. And of course, for him, artificial intelligence is based
请参照语言中心网站老师资料。
on deep learning. He is at the origin of the Ethics Declaration of Montreal. But I have a different approach. For me, AI means augmented intelligence, which aims to increase human intelligence, natural intelligence, using particularly companion. Augmented, for me, artificial intelligence is too artificial. And augmented intelligence concerns everything in relation with the use of digital means to assess and improve the cognitive state of the brain faced to a cognitive task. Here, the companion has evolved since the prince and can see, like Jiminy Cricket, the internal state of the user brain using, for instance, EEG. So in this case, the companion is able to look into the brain and look at the cognitive state of a learner, and using EEG or eye tracking, and provide explanation just in time, relaxing emotional condition, virtual environment, in order to increase the cognitive function. We have applied this system to Alzheimer people using neurofeedback techniques, and we have increased their cognitive and cognitive function and memory capabilities, using relaxing methods in order to reduce negative emotion. So the goal is to improve the cognitive state of the brain. In another application, we have in the pilot AI project with Bombardier and CAE. CAE is Canadian Aviation Electronics. We have developed an artificial intelligence pilot which oversees all the action of the pilot in the cockpit and analyze in real time the EEG of the pilot. And if the workload of the pilot is too high, the companion takes the control of the commands. Here, for instance, we see a workload of the pilot. So, of course, the data are confidential, but when my student gave me this data, I said, oh, this is a good pilot. And they told me, yes, he's a licensed pilot, because the workload is high and decrease and does not stay high, which is the problem of beginners, you know. So this is another pilot company. For me, the future of companions is with generative intelligence. In fact, generative intelligence, we talk a lot about generative intelligence, but generative intelligence for me acts as a troublemaker. Sorry, but ChatGPT provide sometimes right information, sometimes fake news, wrong information. So the user is disoriented, frustrated. So a companion with augmented capabilities should encourage and provoke critical thinking, develop user confidence, because this is the problem. You know, user is not sure. Myself, I experimented ChatGPT. I obtained, for instance, certain reference about conferences. I was happy, but when I look, the date did not correspond. It was wrong. So we cannot give confidence to ChatGPT, and we should develop critical thinking, encourage double check, and develop user confidence with this new augmented companion able to generate human intelligence, the ability to think and have a reflection about data and acquire more confidence. As you know, when knowledge is attached with a positive emotion in the brain, this knowledge is definitively fixed in the memory. So double advantage. So this is my proposition. I'm very glad to have met you this morning.
Thank you very much, Claude, for your very interesting presentation. I think we'll move on to Louis, if you're ready.
I am ready. Let me share my,
yours.
Except I cannot share my screen. Let me try now. Looks like it's going to work this time. So I think this order works very well, Gautam, because I'm going to sort of follow on and assume some of the things that that James and Claude talked about. And I'm going to be focusing more here in my talk on learning companions that are able to engage in conversations with learners. Now, that may be a multimodal conversation as James described, but I think in our work at Alelo, we've come to conclude that really the ability of the learning companion to engage in a conversation with the learner is essential. And we use these for training, for assessment, and we do it for the benefits of the learning benefits that we see, which is that learners are able to develop skills at least twice as fast when they have a learning companion working with them, achieve better retention, build self-confidence, that as they develop their skills in practicing with a learning companion, they're better prepared to apply those skills in real life. We see also that these types of agents make possible much more authentic ways of assessing learners' skills. And I foresee that conventional multiple choice tests will go away, and instead you will have an oral exam with a learning companion who will test your knowledge. That's the way it ought to be going forward. We have, of course, worked in this area for some time, won awards along the way, but I feel now with the advent of generative AI, we're really just getting started. We're now able to really scale up and apply learning companion technology in a much more broadly than was the case in the past. So I'm going to focus on a few examples, past, present, and future. One, I think, is a very interesting case study. This was in the late 2000s. An Army colonel who had learned Arabic from our tactical Iraqi game decided this was such an effective way to learn that he had everyone in his battalion train with our tactical Pashto game before they went to Afghanistan, where they would role play meetings with village elders, for example. And what they saw was that prior to this battalion going to Afghanistan, there were multiple insurgent attacks a day. By the time they left, that had reduced to maybe 1 or 2 per month. A very dramatic improvement in peacekeeping ability. And really what that came from was the ability of folks who had trained to be able to apply their skills, their language skills and their cultural skills in working with people in Afghanistan. So really excellent example of the potential benefits of having learning companions to learn with. Here's a more recent example. We took, and Gautam asked, well, what are some of the key technical challenges that we face at that time? So at that time, and to a major extent even now, people's idea of using AI technology for learning language is that you would present the learner with, say, a sentence, and the learner would speak that sentence, and then they would be scored on their pronunciation. So it was all very scripted. Learner would have fixed things that they would say and be scored on. Whereas we say, well, let's open this up. Let's give learners an opportunity to have a task-oriented conversation with a learning companion and have that be the way that they learned. And so the benefit then was that they're actually practicing applying their skills in real interaction rather than just artificially trying to work on their pronunciation. Moving to more recently, we moved this technology into the cloud, used it for helping learners improve their English conversational skills. So there's a very interesting study that was done at Universidad del Valle de Mexico, outside of Mexico City, where they integrated our Alelo English language training into their English curriculum. They found that the students learned faster, they came to class better prepared, and thereby it made classroom learning more efficient. And from this, we came to understand that although the learning companion has an important role to play, it has an important role to play as part of an overall set of tools provided to instructors as well as to learners. And so this led us to develop our N-skill model for AI-driven learning, where learners do get conversational practice. As they do it, they are assessed in their skills and they get feedback on how well they did. They get personalized practice of additional exercises where they need to improve their skills. And as learners interact with the platform, it is generating analytics. It's tracking learner improvement, learner trajectories, and that is beneficial for teachers as well as learners, as well as program administrators. And another important addition at this time was to make the whole process data-driven. We came to recognize that the data that we were collecting from learners interacting with our systems was as valuable as the learning itself. And so we were constantly capturing data from learners and then using that to iteratively improve performance. Although we did this work initially in English for language learning, we came to recognize that there's actually a wide range of skills, what are often called soft skills, including communication skills, where this type of approach is particularly helpful. And so using this technique, we were one of the winners of the X Prize Rapid Reskilling Competition, where we rapidly retrained people to become community health workers. So the goal here is not to learn a language. The goal here is to communicate effectively with patients to get better patient outcomes. And we followed up, we surveyed employers who had hired the trainees who had gone through this program, and they were very satisfied with the skills that the trainees brought to the workplace as a result of this training approach. So we achieved not just rapid training, but also good retention. So now with generative AI, it's opening up a whole range of different possibilities. And now I'll give you an example from a new training simulation. This is sales training, and you'll see here how the conversational skill is really it's enhancing the learning in a number of different ways. Let's have a look.
It's nice to meet you, Tony. I'm new here in the sales department. What department do you work in?
Hey, welcome to the team. I'm also in the sales department. Been here for about 8 years now.
Wow, that's great to hear. I was wondering, since you have so much experience, Tony, would you mind if I ask you a few questions?
Of course, Beth. Feel free to ask me anything. I'm here to help you out.
Thanks so much, Tony. So I was wondering, what would you say is the key advantage of our company over our competitors?
你就找不到你觉得可以的这样子。
Well, Beth, I'd say our biggest advantage is our team. We're all super dedicated and we really understand our customers' needs. Plus, we've got Sam, my Boston Terrier. He's the unofficial mascot.
Oh, that's great to hear. I'm a dog lover, so I will definitely look forward to meeting Sam. So, Tony, what advice would you give me as a salesperson? I mean, what do you think is the most important thing a salesperson can provide their customer?
Beth, in my experience, the most important thing a salesperson can provide is understanding. Really getting to know your customers' needs and wants is key. And don't worry, you'll get the hang of it.
So, and there are many more examples on our YouTube channel, but you'll see we now are able to create learning companions that are really much more what I think we all envision learning companions would ultimately be. So these are some of the benefits that we're seeing from using generative AI. It supports much more open-ended conversations. The learning companions can actually model the skills that are being taught. So Tony, the fellow that we met there, he is an experienced sales professional, and so he can talk from his own experience. You can see how the learning companion behavior adapts in real time to what the learner is saying. Also, we use this technology to generate constructive feedback, which we believe will help learners learn even more quickly. We're seeing benefits that the development time of creating these learning companions is much less than used to be in the past. And we now envision that it will be possible for our clients or learning organizations in general to be able to create their own AI-powered learning simulations with their own learning companion scenarios. And so this is what we think will be the key to turning this technology from being something that is in some niche projects, turning it into something that is really universally applied. At the same time, we see limitations of generative AI, and I'll just mention a few of the ones that we are grappling with. So what we find is that the behavior of the learning companions using large language models is somewhat unpredictable. And you want some degree of unpredictability, but not to the point where the training becomes inconsistent. You can't trust the learning companion to provide a consistent training experience. We find it's not particularly good at generating consistent evaluation metrics. Although development time is reduced, still testing and iteration is needed in order to get the learning companion behavior to be just right. The response time, you may have seen in that video, is still too high and needs to be improved. Unfortunately, the large language model providers, OpenAI in particular, have set very high prices for the use of their technology, and that could become a barrier to adoption. And then finally, we've seen how this past week, there's just so much chaos in the generative AI industry, and that really is a concern for those of us who are relying on this technology going forward. So I'll stop there. I'm sure we'll have further discussion on these topics later on.
Yeah, thank you very much, Louis. Let's continue. Art, are you ready to go?
Yes, I am. Can you hear me?
We can hear you.
Yeah, and can you see my screen?
Not yet.
Okay, it's maybe on another screen. Can you see it now?
No.
Can you see it now?
It's coming up.
It is?
Yeah, you're on.
Okay, good. So I'm so happy to be invited to this event, and I'm going to talk about the role of ChatGPT in these adaptive artificial learning companions or conversational agents or whatever you want to call them. So I listened to the previous presentations and I had a deja vu. I mean, look at these. I mean, think of what James Lester said. He talked about Steve. He talked about Betty's brain, Herman the bug. And I give about 100 of these presentations in the last 5 years. And these are the people, including, these are the people that created the history on this. Louis Johnson's award-winning event and everything. Of course, you got to include Memphis. Memphis was one of the core groups that created a lot of these. Auto tutor, I'm proud of, in computer literacy and physics. There was biology, there was reading comprehensions currently, there's algebra that Cheng-Yan Hu led, and the HURA advisor on ethics, scientific reasonings. We actually commercialized a game with these agents with Pearson Education before the Common Core came on and killed a lot of their technologies. And not from Common Core, but because of various politics. But in any event, there's electronics tutor now in the Navy. And imagine an agent that follows you throughout your life. That's the personal assistant for lifelong learning in our collaborations with the Institute for Creative Technologies at USC, University of Southern California. So a lot of agents. We like to have multiple agents. We like an expert agent and a fellow student. And a lot of these systems, including Claude's, have these where you can see an expert interact with a student, or the traditional tutoring with an expert interacting with a human learner. And then the teachable agent, where the human tries to teach an agent. So I really love these trialogues. So what are the discourse mechanisms behind AutoTutor? Well, AutoTutor doesn't simply lecture. Instead, it tries to get the student to do the talking and doing. That's fundamental. This is part of constructivist learning. It's not just a fire hose of information from a system. It's to try to scaffold the student to do and talk. And that's what we try to do. And we have what we call the expectation and misconception tailored dialogue. We came up with this after analyzing thousands of hours, not thousands, many hours of transcripts of human tutoring. What do human tutors do? What they do is present a difficult problem or a difficult question, and they have these expected ideas to be covered. And they anticipate various misconceptions. And as they hear the actions or the talk and the actions of the student, they compare it, semantic matching and matching, pattern matching to these expectations and misconceptions. And what they do is try to fill in the gaps. That's what they try to do. Or if a misconception occurs, they try to correct it or try to have a dialogue move to get them to think about it. So there's many important dialogue moves. There's deep questions, pumps, hints, prompts for a specific answer. Sometimes you can't get a student to express even a word, and so you need a good leading question to get them to do that. Requests for summaries, feedback on how they're doing. So it's a conversation. To answer a difficult question, it may take dozens of dialogue moves back and forth in order to answer that question. So that was the vision, to try to emulate human tutors, and the expectation and misconception tailored dialogue was what it was all about. So ChatGPT arrived about a year ago. And so there's a question on how you can recruit these systems to improve these adaptive intelligent tutors. And by the way, before I go further, all these systems that I mentioned before, they showed that it helped people learn. In fact, we have many studies to show that these computer tutors are about as good as human expert tutors. And it's better than having people listen to lectures or reading a book. So they're effective. And doing those studies to show the effectiveness is very important. So how can we use ChatGPT to enhance the enterprise? That's the question. It's important to understand that ChatGPT generates information in response to a prompt, like a question or a request. It delivers information very impressively, and we know all about hallucinations and misinformation. You know, I have confidence that the future AI will figure all that out. You know, I'm not as concerned about that. But ChatGPT has no model of what the student knows. So it does not systematically participate in a multi-turn conversation. It really doesn't. So the conversational threads, there's a breakdown. And so the question is, can clever prompt engineering emulate conversations that help students learn despite these blemishes? Or what is the half-life of a coherent conversation with ChatGPT as a tutor? You know, so I want to just refer, I'm now retired. I'm in the middle of my 5th year of retirement, but I still am involved in project with Sheng-Yen Hu, John Sabatini, and other people, you know, but leading none, but I'm still active. But so I want to talk about 2 projects of collaborators. One of them is at Carnegie Mellon with Tom Mitchell and his collaborators, where they're trying to have an automated intelligent tutoring system induction. So the idea is they want a domain-independent conversational intelligent tutoring system. And I don't know who that was, but you know, but so
that they would also see, because when all the program, the high-low are also at least several high-lows because they are all linked. So
the moderator, please mute everyone.
So do the
okay. All righty. Sorry about that. There was a technological glitch. So imagine, once again, they have 2 agents here with a role of student and as a professor, and they try to implement expectation and misconception tailored dialogue. And so for some reason, I can't advance my slide. Okay. So the system is called Ruffle and Ready. And here's the architecture. They take existing content from an ebook, right? And they generate a script. And part of that script with a question, they have many expectations. They generate the expectations and the expectation and misconception dialogue. Then they have a conversational system and a dialogue manager that automatically generates these tutorial dialogues, okay? And so here's the interface on that. And as you can see, there's a free-form dialogue at the left. There's the text that they automatically put in there. There's intelligent feedback on what they say. If the student, and there's 2 agents. There's the tutor, but there's also and the student, but they can ask for expertise on demand on how good the conversation is going. And if a misconception occurs, they can try to correct it. So this is an example, and you can contact them on more details. but two agents. And it's really a teachable agent in this situation where the human tries to teach a computer agent by answering the questions. And but then they, like in Betty's brain, they have an expert that looks over this. So they're trying at Carnegie Mellon to do this. The other example I want to have is my good friend Sheng-Yen Hu, who I've been partnering with for 30 years, with his Socratic playground for learning. And what he does is use sophisticated prompt engineering for different tutoring styles and pedagogies. Imagine you could have many different styles of a tutor, not just one. And Sheng-Yen, who has been developing this while he's been on sabbatical all over the world. And unfortunately, he's leaving Memphis to go to Hong Kong Polytechnical University. So for those of you in the Asian communities, you might want to seek out Sheng-Yen Hu for collaborations. But his playground has many different resources, not just conversational agents. It has the Socratic interaction, but it also helps both students and teachers learn about Bloom's taxonomy, American Psychological Association, 20 principles to help people learn, teachable agents, self-reflections, even game environments. So this is a playground for students to learn and also for teachers to help them train students to learn. And he uses generative AI in this trialogue situation with a tutor agent and a fellow peer agent. A lot of these systems have that multiple agent sort of situation. And so I'm just left with research questions of the future. So can clever prompt engineering emulate conversations that help people learn in spite of the limitations of ChatGPT, where there's no student model? And what is the half-life of a coherent conversation with ChatGPT? And people can measure that. You know, at what point does conversational coherence break down? And my belief that the value of ChatGPT is really to help people with inquiry learning, you know, where students learn how to have good prompts to create products, and self-regulated learning and the critical thinking that Claude mentioned. That's where I think the value of ChatGPT is, but perhaps it can handle all of these challenges for tutoring. So thank you so much. Those were my ideas in this very exciting sort of symposium, and I look forward to see how all this evolves in the future.
Thank you very much, Art. So we've had a lot of very interesting perspectives, but last but not the least, Chen-Chung Liu, please.
Okay. Can you see my slide?
You're
okay.
Go ahead.
Okay, it's my great honor to here to enjoying this wonderful panel. I'm not a good old AIED person, but I started to investigate the influence of AI on some learning about science and reading. So I think most of you have known the Two Sigma problem. 37 years after Skinner's program instruction machine, now we have large language models available for us. I think it is a very powerful tool, but we have to test many things before we use it in our education system. our team has been working on the artificial tutor for in the past few years. We are to develop the artificial tutors as a company, as kind of learning companion, to talk with students when they are reading a book. And our goal is to help them to build their reading interest at an early stage. This is how it looked like, and when children are reading a book, they could talk with the artificial tutors or companion, and they could ask questions, and the companion will also ask them questions. Before when we were developing the system, we do not have large language model, so we use several AI techniques in ALN and NLP. And for example, we use coreference resolution to refer the pronouns to their corresponding nouns to understand who is the main character of the story. And we also apply the dependence parsing to see the basic structure of the sentence, so to understand the actions the main character has done in the story. Also, based on the content knowledge we obtain from the story, we could propose some storyline questions to students, and they could also, the student could respond to the questions. And we also apply some conversation framework in the tutor. So for example, we use the Kurishita's book talk strategies that include opener, rejoiner, shadowing, and following up to help the tutor to conduct the conversation with the students. So after several rounds of interaction with the artificial tutor, we found students perceived high level of social connection with the companion. They like the companion, and they feel the companion is intelligent, but they feel a little bit low level of anthropomorphism. That is, they don't think the tutor, the artificial tutor, is human-like. We also measure their interest in reading. We found that the interacting with the chatbot, the artificial tutor, it would be helpful to maintain their interest in reading. Okay. So we also developed another tutor, or artificial tutor, to act as the book talk facilitator to facilitate the book talk between two students. The framework we apply here is the APT, Academic Productive Talk, that emphasize the learning community building, that help students to link contribution and idea exchange between peers. We do find some very positive react from the students. We found very strong social learning evidences. For example, the student will question the chatbot and also the peers. They were asking response from the chatbot and from the peer. They will also correct the peers reply, and they also mention peers name when they talk to the chatbot. So in brief, our experience showed the artificial tutor exhibit great potential in initiating and facilitating dialogic learning activities. But our artificial tutor was still quite limited in detecting the atmosphere and the context of discussion, because we do not have a large language model at that time. I do a very rough estimation about the effort we put in different parts of the development of the tutor. I think the system interface and networking is quite simple for us. So we spend only 20% of our effort and time to develop the system interface and the networking, but we spend about 80% efforts to deal with the NLP. So I think that the large language model available now is quite promising for us to develop this kind of artificial tutors. So I propose to potential direction for the use of the large language model which is can go beyond the intuitive imagination of large language models. The first one is artificial tutor that support reflection in action through multiple representations. And the other is teacher craft tutors that will unleash the power of educators. This is the model that I understood about the application of large language model in the development of artificial companions. Basically, we have to give the large language model some learning content that will constrain the generative AI to generate the response according to the learning content we give to them. And then we will give them some prompt, give it to some prompt based on some pedagogical principle to hint the large language model how to produce the feedback. And then we give the conversation history to the large language model, and this language model will produce the feedback to the students. This model, I think, is interworks to student based on the verbal and text data. But I think we all believe that the cognitive apprenticeship theories very stress the critical role of the coach to observe students' actions and to help them reflect in action. That's what we know about reflection in actions. So I think we should include some in addition to the conversational data, we should include the learning action history in the context to the large language model, so that the generative AI could generate appropriate feedback according to the student's situation in the context. So over the past 10 years, we have been working on the development of computer science simulation for high school students. We now have over 150 computer simulations available on Cosine. If you are interested in it, you could Google cosine.tw, and there is also an English version. And our next phase, our goal of next few years will be developed a artificial tutor for each of the simulation here. This is the scenario we are of how the artificial tutor could be used in our simulation. This is a simulation that in which students could use to learn the circular motion. They could operate the velocity and the friction coefficients, and they could check the how can the car pass the turn safety under different weather conditions. So the artificial tutor will observe student inquiry actions in the simulation and help them to go through the critical inquiry process. When students are using the simulation, there will be a tutor here to help the student to explore the simulations. So here I took some example of the ChatGPTs, the feedback to give to student when student come to the simulation. After a couple of trial of simulation, the tutor will introduce the inquiries questions. How do you think the vehicle speed v and the static friction coefficient mu will play a role when the car is turning? And after a couple of rounds, the tutor will suggest an experiment plan. So you are going to test the simulation where the static friction coefficient mu is 0.2, 0.4, 0.6, and the tutor will observe student action and give them some feedback. So because the tutor understand the context, so it could give some suggestion to the student. This, for example, it would say this. It says the results show that something about the result of the simulation. How do you think the variable should be adjusted to successfully pass the curve? And finally, the tutor will help the student to make conclusion. For example, it said, based on these observations, can we initially draw a conclusion about this? This content is generated by GPT 3.5. I think it's quite promising because we are doing some tests for the possibility to include the tutors in our cross-science platform. So I think the intelligent tutoring system will be even more important in a complex environment in the future. This is one of our work, AI enhanced physics lab here. It includes several representation of science. For example, it has real instrument here. It has virtual simulation on the transparent screen. It has paper worksheet, and the AI tutor is quite important to integrate all the resources together. For example, the image processing AI will receive the image camera to detect the actions of the students, and then give feedback to the students when they are doing some science experiments. And this could be also done in the AR system here. Yes, here the AR system, the artificial tutor could give the students feedback while they could show the optical path to the students here because they understand the situation of the context. The second direction, I would say, the teacher craft tutors. This is the news from a university press. Dr. Wang, who I met once in a conference, he and his team crafted a AI tutors to help students to learn science, to learn physics, and students in the university just like the show very positive reactions to the system. So I think this is because the artificial tutor will be getting easier to design because we only have to provide the prompts. This is the prompt we provide to the GPT. I think it's quite comprehensible, and the teacher do not have to write very complex program. So I think it's possible. And I think it is also equivalently important to empower teachers to craft their own artificial tutors, because teachers know their students better than us. And I believe the teacher craft tutor can be as important as a textbook and other resources. So I will propose two open questions. One is social connections with the artificial tutors. They can be friendly, they can be intelligent, and they can be even human-like. However, who are they, and why students wanted to talk with them? And the other is AI is not free. We did a very simple experiment. We invite 20 students to learn science in cosine with artificial tutor for 30 minutes. And the OpenAI charged me $5. It's not a big deal, but we have 70,000 regular students per month. So if each student come to here to use the ChatGPT, to use the artificial tutor, it will cost $1,750. So who will pay this? If the teacher, no teacher will do it. If it's a student, they will widen the digital divide. If it is a content provider like us, who will bear the cost finally? Thank you. This is my presentation.
Thank you very much, Chen-Chung, and I'd like to thank all 5 of the speakers, the panelists. Very interesting talks. We'll open it up for questions, and I thought I would start with one generic question based on your presentations, and then let each one of you respond. And then in the remaining time, we'll open it up for questions from the audience, or even questions that panelists want to pose others. So we'd like an open discussion. I want to start off with this. So if I were sort of just observing the five of you and sort of the presentations you gave, there seem to be two things that are happening because of the advances in technology. It's not just generative AI, but all of the other accompanying technologies that are happening. One thing that's happening is with these artificial learning companions, for example, Lewis's work, you're taking your companion out with you into the real world and learning as you're operating or performing. In other cases, for example, like James and Chen-Chung, you're bringing in the real world into an environment where students can actually learn. And in both of these situations, we want students to learn through social interactions. You presented various kinds of companions. They could all the way from teachable agents to tutors, but all kinds of companions in between. So the question to all of you is, right, so to think about, say, 5 years down the line, where do you think technology will take us, and what do you think these environments are going to look like? And any one of you can start, but it would be great to hear from all of you one by one.
So I can comment on a piece of this. You mentioned just in passing in your really interesting question, this issue of collaboration and students or trainees working in groups. So I think we would all probably agree that collaboration is kind of a first-class skill. It's going to be significantly elevated with the emergence of AI. So that seems pretty clear. But it poses a super interesting tech question, which is we are, by this point, understanding student modeling reasonably well, at least for much of the cognitive piece of it, and to some extent the affect and motivational piece of it. However, we don't have a good understanding of group student modeling or aggregate student modeling. And I think a super interesting area of work over the next 5 years is understanding how students learn in teams, how they develop collaboration skills, and how we're going to adaptively support these. So in addition to it being a super interesting technical question, the last comment I'll make is that I think there'll be such a demand for this set of capabilities that enormous investment is going to go into it. So, we're all but assured of having some solutions to this problem, and it'll be really fun to see how it unfolds.
Great point, James.
So I want to make a pitch for one of my last points, that I think the generative AI and these agents can really help people with skills, 21st century skills, like self-regulated learning, inquiry, critical thinking, and where they get to see agents that model this and interact with that. And I think the future is more in that area, and including collaboration with other people, as opposed to this kind of tight dialogue on subject matter content.
Exactly.
That has been a big part of the past. I've been a sinful person in that area, but I do think the future is this broader part rather than this knitting of covering specific topics. Yeah.
It's a great point.
Can I add a comment? Yes. Art talk about possibility of misconception, and this is true. With ChatGPT, we have a possibility of a propagation of a kind of a virus of wrong information. And presently, we have no means to detect wrong information from the truth. maybe ChatGPT or OpenAI or other company will be able to improve their product. But from a teacher point of view, our responsibility is to propagate the true information. And for that, one of the present means is to develop, as I said, critical thinking with students in order, 30 years before, we could absorb wrong information being ignorant. But now we need to develop human intelligence faced to the flow of information and have kind of reflex of a student, of learners, and any user to think about the validity of the information. And so this is why I see a long future for companions. We need to have help and to balance the negative impact of some negative impact of the technology.
Yeah, I would agree with James that when we are using GPT to generate feedback for students, I think we found it's quite difficult to model students. The GPT will forget who they are talking to and forget something if the dialogue is long. So I think in the future, I think there will be multiple agent system. There's some in which some agent will be in charge of the student modeling, and it will give feedback to the conversational agent, and to give the conversation agent a hint of who is the student and what is the status of the students. I think it's quite complex for individual agents to deal with all these things. So and some colleagues will they also ask me how to verify the feedback of the GPT is correct or not. We will say maybe we should have some verified system to use different models, different large language model to verify with each other, so that there could be provide very consistent and secure answers to the students. And this is one of our approach. And the other thing I would like to add is because students only learn with the GPT on a verbal basis, they would just talk and they do not do anything. So I would say that maybe it's quite important to integrate more representations in the real context. Because the Vision Pro and the HoloLens, this kind of AR system is is very mature right now. So it has become very possible for the integration of this kind of vision, AR-based and the large language model together to help students to learn in the real context. Yeah, this is what I think.
So we're really in early days here in using this technology. And I think one thing, first of all, we're not talking about using ChatGPT. We're talking about using large language models to model effective tutorial dialogue or effective learning companion dialogue. If you just use ChatGPT as it is, it's really designed as a chatbot, and that's what you're going to get. But I think in 5 years, we will learn how to model dialogue effectively. I mean, we're making good progress, but we're still learning how to make it work. I think where it provides, if you will, part of the solution. What I hope is in 5 years, we will be able to create models that on one hand are making best use of the large language model, and on the other hand is taking advantage of the data that we're collecting from each learner to build that learner model that Art is asking for. It can be done, but we're still figuring out how to do that. I think that's the big challenge for the next few years.
So I agree with Louis. I'll be brief. I see ChatGPT as a sequence of two-step dances. It's prompt response, then another prompt response. They take the context into consideration, and it's a sequence of two-step dances. And so how can you coordinate the two-step dances into an interesting dance? And that I don't know. And it'll be interesting to see whether it can be done. Yeah.
Yeah, those are all really interesting points. So, I mean, what I take away from what you all said is, starting with James. So we're talking about interactions between, say, agents and humans, right? And we are using, large language models, or maybe ChatGPT in particular, to do that. And Art, you presented, that's absolutely true. These are just sort of two-step models, and you presented the idea of how we might add more context by having learner models, and Louis said that too. But yeah, again, the big question is, how natural are these conversations going to be, especially, say, in a real environment, again, where you may have a few human students and maybe a few agents, as you all are proposing, right? So how do we get from, say, where we are now, right, to having those kind of conversations, right, which is an extension of this collaborative learning idea that you mentioned, James, and the rest of you sort of presented ways in which we might achieve that.
What we're finding, Gautam, is that the conversations are much more natural than was the case in the past. It is a marked difference. Where it is a challenge is to maintain that naturalness over time.
Right.
That these large language models tend to get lost in the conversation after a certain period of time. So that's one of the limitations that we in this field now must work to overcome, to take advantage of this. But on the flip side, it raises us up to a much higher level in terms of natural conversation. We're in a much better starting point than we ever were before.
Yeah, I should give Takwai a chance. Takwai, you had inserted the word humane into the theme. So maybe you have something to say about that and ask the panelists questions about it.
I put the humane there because in general, especially in Asia, education is something very difficult, very tough for the students, or inhuman, not so humane in general. But however, we researchers here are so happy working on new technology, how to enhance our future learning and so on. But in fact, the learning process of most students in Asia are not so happy. So we want to have some humane learning companion. That's what I want to. So furthermore, I would there's some remindings here. I think I'm kind of a person more historical thinking. So in this area, to many researchers, they are the new researchers. And we are the old researcher in this one, and in a way, so I think it's very important to let the new coming researcher in this area to know about our past work. So I would like to, if possible, I would like to after this panel, I will ask you to list some papers you have been working for. You want other people to read about the papers, and then we will put it on the web. Also, if it would be nice if you can give us the presentation PDF and then put up over there some logistics. And here I would like to mention one thing. I'm kind of I think Gautam know about that. Talking about the global educational problem. Global educational problem, which I mentioned in my keynote 207 in AIED. And we have some idea about that after exchanging with many Asian researchers here. And then it will be the global global harmony and well-being. And then one thing we will talk about, one component we will be talking about is the future digital world. And then we think it would be something like the seamless AI world. And then what does it mean by seamless AI world? It will be a notion or concept. And then I hope some of you can help us to define and then describe this concept in the future. Anyway, I will come back to you later on. So let me see. Just remind you. It would be nice if you can leave your presentation PDF for us and then put it on the web, and also some of the paper you want other people to read. Okay, thank you for joining this very nice panel. Thank you.
Thank you. So this being being held virtually, we cannot clap to thank you all, but I really appreciate all of the panelists and for your very interesting presentations, some discussion at least. Thank you to the audience. There were so many of you for staying back and listening. If you had more time, I hope we would have had more discussions, but I'm sure Takwa, you'll arrange more of these in the future. So,
okay.
Yeah.
Thank you
very much.
Thank you so much, everybody.
Thank you for organizing.
Thank you.
Have a good day, night, or breakfast, or middle of the night.
Well, for me, it will be breakfast. Thank you to everybody.
You can have early breakfast, very early breakfast in France.
Yes, an early breakfast. Yes, at 4 in the morning.
Yes.
Okay, thank you.
Thank you.
Thank you, everybody.
Bye.
All right.
先回答个是哪个是